Good afternoon to all. The lecture today we're going to start is that how to delete an element from the linked list. So deletion is not a single step that you select the element and delete it. So it's multiple steps are being performed while you have to delete an element from the linked list. First of all, we select the element that we want to delete. Then we insert that element at particular location. Which location we want to insert, we have to get the location also. And after that, inserting the element in the linked list, we have to change the address of the previous node because it's inserted in between the two nodes. And as well as we have to change the address of the inserted node, that what is the address of the next node of the linked list. So it is not a single process. Multiple operations are being performed whenever we have to delete an operation from the linked list. Similarly, when we delete an element from the linked list, if the element get deleted, then the address of the previous node will also get changed. Earlier, the previous node was attached to the deleted node. So when the node got deleted, that previous node will attach to the next node to the deleted node. So let's start our topic with the deletion of the linked list. The deletion of a node from the linked list can be done from any location. You can delete the node from the front side, that is the first node. We can delete the element on the first node. We can delete the element or node in the last node of the linked list, or we can delete the node in between any location in the linked list. So we have to find the location and delete the node, as we have done in stack and queue. That in stack we can delete the node that is only on the top, whereas in that is in stack last node inserted is the first one to be deleted, whereas in case of queues, the first node that's inserted was the first to be deleted. So we have options of this option over there that we can only delete the last node or the first node in case of stack and queue, whereas in case of linked list, we can only we can delete any node that we want to delete from the linked list. Just give the location of it, either it is in the front or it is in the last, or it is in the in between of the linked list. So it's not a single operation that we have to perform to delete, as we have did in the stack or queue. Just select the first node in like in queue, or just like the last node just like in stack and delete it. No, but in this case of linked list, multiple operations are being performed whenever we have to delete an element from the linked list. So deletion is also a more than one step process. First, locate the target node to be removed by using searching algorithm. So we search the node, which node we have to delete. Then the left, or you can say previous node of the target node, now should point to the next node of the target node. Earlier, the previous node of the deleted node was having the address of deleted node, but once we delete the node that we have selected, the address of the previous node will become the address of next to the deleted node in the linked list. So a little bit more operations are being performed instead of single operation. So we start with the deletion process. So if we are having a, you can see we are having a linked list with 3 nodes over here, head pointing towards the first node, then the first node connected to second, second connected to third, and the third is having a value null, that is no further node over here. So if I want to delete the second element over here, earlier you can see over here that first the node was having the address of second node, and second node was having address of third node. So once I remove the middle element from the linked list, now you can see the first node is having the address of third node, which becomes second node. So you can see over here, now once I deleted the second node, so address of the first node now become the address of the node that was next to the deleted node. So in such a way, multiple options are being done. First, I select at which location my node is, which data element I want to delete. I search that node in the linked list. If I found it, then I will delete it. If I unable to find that node, then I send a message, the node does not exist. So once I found the node in the linked list, I select that node and remove that node and change the address of the previous node. That is the next address of the next element in the linked list is the address of the next node to the deleted node. This is how the multiple steps are being performed whenever we perform the deletion operation in the linked list. So you can see over here, start is 109801 is the address of the first node, value is 22, and 109821 is the address of the next node. You can see over here, this is the address of next node. Next node is having value 57 and having address of next node. You can see over here. And again, that's having value 8. And this was having the address of next node. That is this one, having value 69. And further, no nodes are there. So it get the value null over here. So I'm having a linked list of 4 elements, 22, 57, 8, and 69. So delete first element of the linked list. If I delete the first element, then the starting address will change. If I delete the first element, the point that starting the node got changed. Earlier, the starting address was 109801. If I delete the first node, it get removed, and now it starts from 109821. So this is how I have to change the address of the starting node if I delete the first element of the linked list. And the first item is having the value 22. And you can see over here, start of data become item, whatever item I have deleted, and start become this 109821. So if I delete the first node got removed. You can check over here. Earlier it was having 4 nodes, now it's having 3 nodes. The first one is deleted. Now the starting address is also got changed. Earlier this starting address point towards this node, that was starting node. If I remove this one, now this become the first node, and you can check over here the address of start also gets changed because the starting node is again get changed. So earlier it was having 4 nodes, now it's having 3 nodes. This is how I can delete the element either from the first or from the last or from in between over there. So let's move further. Algorithm to delete an element from the linked list. So here we take some algorithm that how to delete an element from the linked list, either from the first location or from the last location or from any location in between the linked list. So DELLL, then this is the name of the algorithm. Item, data, next, start, temp, hold are some of the important variables or parameters I have used in my algorithm. I mentioned over here that DELLL is the name of the algorithm. Item is the item that I want to delete from the linked list. So item holds the value that which element I want to delete. So data is the item at the current location. Data is the item that I'm having the current location. So if I'm having the first location, then whatever the value the first location is having, that becomes the data. Then next is the address of the current linked list element. So next holds the address of the next element to the current node. Start represent the first element of the linked list. Temp is a temporary variable I have used, which is helpful to me when I go for the designing of the algorithm. And hold is also a temporary variable that I have used to put some value over there. So temp and hold are 2 temporary variables that I have used, and del, item, data, next, start are some of the important variables with the help of whom I can delete the element from the first location or from the last location or from the any location in between the linked list. So let's move further. So every algorithm starts with the first point as a start. So input the item that to be deleted. So I check at which element I want to delete. First of all, I start data. Is the item that I select is the first item? So if start of data is equal to item, this means that we are checking that the element we want to delete, is it at the starting of the linked list? So if start data is checking that if the element is the first element of the linked list, uh, then temp, if it is a yes, it's the first element of linked list, then I use the temp variable as start. So temp variable is holding the value of start. Then start become temp of next. It means that earlier starts from a particular location first node. Now start have deleted the first node. Now you can see over here in the fifth point, start is equal to temp of start. What is temp? Temp is start. So you can write over here, start is equal to start of next. So whatever the element next to start is, that become the first element over here. So it means start is equal to temp of start. Second element will be, now the link will start from second element because the first element is deleted. Right. So the from point 1 to 7 means that if the element we want to delete is the first element in the linked list. So hold again is a variable, temporary variable I have used over here. It's holding again start variable. So eighth point will occur if the if condition in the point 3 is got false, that the item that I have entered is not the first item. The item that I want to delete in the linked list is not the first item. If this become false, then step number 4, 5, 6 will not run. So they got just discarded if this is false. So I go to the instead, if this becomes number 3 become false, I shift to directly to number 8. So then hold becomes start. Temporary variable hold get the value of start, and a loop will run and hold of next to next become null. That it will check the hold of next, the whatever the next variable is, and then next to next variable having the value null or not. So we're checking over here condition, we have put a loop over here. So if hold of next of data is equal to item, so hold is a particular location, next means next element, and next element data. So we are checking that the next element, the first element is start, fine. So this is not a first element, it means hold of next becomes the second element. So is the second element data is equal to item, that item is that particular value that I have asked from the linked list to delete it. So the number point 10 is asking me to check if the second node data is equal to the data I have entered. If it becomes yes, then temp again is a temporary variable, and that holds the value hold of next. So hold of next means this becomes the second point, second uh, node of the linked list, because holds go to start, it means first point, and temp of hold of next means second point. So temp holds the address of second one. Then hold of next is equal to temp of next. What is hold? Hold is start. It means the starting point next value now join to the temp of next. What is temp? Temp means second node, second node having a particular value of next element. Now that value will become the next element of first node, and temp become null. So you can explain. I will explain all this with the help of an example. So if this from step 9 to step 14, if that element lies between, neither is the first element nor it is the last element. So 9 to this all will perform the operation. If 9 to 17, if it is neither the first element nor the last element. If hold of next of data is equal to item, then I will change the value of the item. So let's see how it performed all the operations. Let me elaborate this algorithm with a little bit practical to you so that you can understand all the concept of it. Uh, if I want to delete a third element of the linked list, if I want to delete the third element becomes the item that's holding the value 8. So the value of my item is 8. That I want to delete the item that is having the value 8. So you can check over here. Because it is not a first element, so I can reject the point number 3, point number 7. this rejected because I'm not deleting the first element. So I start from 8 point. So I write over here hold is equal to start. You can check over here hold is equal to start. It means hold is having the address of first element. It means hold is over here. Fine. Right. Then I put a loop over here to find well until the hold of next is not equal to null. So hold is equal to start. Item is 8. 8 means what item I want to delete. And hold of next of data is not equal to item. This is hold. And hold of next is this one. Hold of next is second node. And the data of this one is 57. Hold of next of data. This is hold. Hold of next become this one. And data over here is 57. Is 57 is not equal to item? Yes, it's not equal to item. Then hold become hold of next. Hold become hold of next. And what is the hold of next? Hold of next is 109821. That is this one is a 109821. Now this become hold. Now this become hold. You can check over here. This become hold. Fine. Now you can check over here. Hold become 109821. And item I want to delete is 8. Is hold of next of data is equal to item. This is the hold. Hold of next is what? This one. Is the data is of this item is equal to the data I want to delete? Yes, because this is 8. And what I want to delete? I want to delete the node with having value 8. Here it become true. This become true over here. Fine. So I take a new variable temp and assign the address of this node to the temp variable. Fine. Hold of next. This is hold. This is next. This is hold. This is next. You can check over here. Hold of next. So this is a hold of next is equal to temp of next. What is temp of next? 1098333. So it means this value get changed. This value will become 109833 because I want to remove this particular node. I found the node having value 8. So I removed the node, and what I did is I changed the address of the next node of the second node. Earlier, second node was having the address 109811. Now you can check over here. The second node is having address 109833. That's the address of this one. Address of this one. Right? Earlier I was having 4 nodes, 22, 57, 8, and 69. Now I'm having 3 nodes because the node having the value 8 is get deleted. So this is how the algorithm works, how it finds the location, and how the temporary variable hold and temp help us to find the location of the variable and help us to change the address of the previous node of the deleted node. Okay, that deletion of an element in the linked list is not a single process. So in the first stage, I start searching the element. Is second element is the element I want to delete? It said no, this is not the element that I want to delete. I want to delete element 8. So I'm searching. When I shift to stage number 2, then I found that element I want to delete is at location number 3. So I search the element that I want to delete. It means my searching is over now because I found the location of the element that I want to delete. So one operation is finished, that is the searching. If searching get finished, now deletion gets started. At this point, I delete the node that I want to delete from the linked list. It means first I mention the which node I want to delete. First step, second step, start searching that node in the linked list. If you are unable to find, you cannot delete. If we find that node in the linked list, then the searching step is over. Then once we find the link node in the linked list, then deletion process will start, and we delete that element from the linked list. And it means nearly about 3 to 4 steps are being performed whenever we have to delete an element from the linked list. So this is how the deletion can be done in case of linked list. So in this example, I want to delete the element that is having the value 69, the node having the information 69 in the node. So I'm having four nodes in the linked list. So I start by searching. First of all, searching process will start. So I start with the first node. First node is, I called it as a hold. So hold become 1098 uh, 01. Hold is start. Start is 18901109801. This become hold. Item is 69. That's the item having value 69. I want to delete. And hold of next. Hold of next is what? 109821. This is the hold of next. And data. Data is this one. Data is 57. So hold of next of data. Hold of next of data become 57. Is 57 equal to 69? No, it is not equal to 69. So 57 is not equal to 69. So I shift my hold from first location to second location. Now hold become 109821. Fine. So I write over here hold is equal to hold of next. Hold is equal to hold of next is this one 109821. So this become hold. Again my search process starts. Hold become 109821. This is a hold. Item I want to search is 69. Hold of next is this one 109811. This is the hold of next, and data over here is 8. So hold of next of data is 8. Is 8 is equal to 69? No, 8 is not equal to 69. Then what I do is hold is equal to hold of next. This is a hold, and hold of next is this one. Now this become hold 109811. If this become hold, hold is equal to 109811. Item I want to delete is 69. Hold of next of data. This is a hold. Hold of next is 109833. This become hold of next, and data is 69. And data is 69. Hold of next of data. This means 69 is equal to item is 69. This become true over here. I found the location where 69 is there. Fine. So I use a temporary variable. In which I save the address, that is 109833, and hold of next. This is the hold of next. Fine, is equal to this temp of next. Temp of next is null because there's no further element over here. It means this null will shift from here to here. This hold of next is equal to temp of next. So this shift over here, and hold of next will become was this one, and now over here it will come null over here. You can see over here after deleting this last node, the null is shifted back to over here. Earlier I was having 4 nodes, now I'm having 3 nodes because I have deleted the last element from my linked list. This is how I can delete the last element from my linked list by using the deletion algorithm in the link. Next topic of the linked list after deletion is the doubly linked list. So doubly linked list is a variation of linked list in which navigation is possible in both the ways, either forward or backward, easily as compared to single linked list. So following are the important terms to understand the concept of doubly linked list. So doubly linked list have each node have 3 parts. Each node have 3 parts. First is the data. Each node of the link can store data called element. Then next, each node of the doubly linked list contains a link of the next node called next. Then this become previous. PREV is the previous. Each node of the doubly linked list contain a list or link of the previous node called PREV, and the last node carries the link called null to mark the end of the list, and the front node carries the previous link as null, as there is no previous node to the first node. So it means doubly linked list is a linked list in which each node of the doubly linked list have three parts. The first part is the data. Second represents the, we can say, next element address, and third represents the address of the previous node. So this is how we can represent a doubly linked list. So I have mentioned start, that starting node is the node at address 109801. So this is the previous, this is the data, and this is address of next node. So if I am at first node, so there is no node previous to the first node, that become null value. So the first node is having value 22, and the next element to the first node is at location 109821, that is this one. Now if I am at this location, then the previous node to this location was at location 109801, that is this one. Value is 57, and the next node to this node is at location 109811, that become this one. If I am at third location, then this value shows the address of the previous node, that is 109821, this one. It become the data element, and 109833 is the address of this node. If I'm at this node, then the previous node having is the address of this node, that is the 109811. 69 is the value. As it is the last node, no further nodes are right over here, none. So this is the way how I can represent a doubly linked list. So start holds the address of starting node. Start holds the address of starting node. The first node 109801, the first node 109801 has previous link as null, and the next link is 109821, and the next link is 109821, and data is 22, and and again the next node 109821 has a previous link 109801, 109821, that is this one. This is the previous 109801, and next is 109811, and the next is 109811, and the data is 57. So the last node has a previous link. So this is the last node, has a previous link 109811, that is the 109811, and the next link is null. And the next link is null because this is the last node, nothing is ahead of it, and the data over here is 69. So this is how we can represent the doubly linked list, and various operations that can be performed is traversing to access each node of the linked list, either forward or backward at least once. Insert to add the new element in the linked list at any location. Delete means to remove the existing node in the linked list from any location, and searching is to find whether the given node is in the linked list or not. So these are the various operations that can be performed in a doubly linked list. After a doubly linked list, we have next a circular linked list. So circular linked list is a variation of linked list in which the first element points to the last element, and the last element point to the first element, if we talk about the doubly linked list or simple linked list. So circular linked list is a variation of linked list in which the first element point to the last element if we are having a doubly linked list, And if we have a simple linked list, then the last element will point to the first element. So both single linked list and double linked list can be made into a circular linked list. So in this figure, you can see is a linked list. You can see single linked list in which the last element, you can see the address of the next element is not null over here. So we represent the address of the first node. That is here you can write over something that wrong over here. You can write over here 109801, but not 21. Here we have to write 109801 because 01 is the address of the first node. So 69 is the value, and the next node value will be the 11098001. So you can change it from 21 to 01 because the first element having the address 109801. So this is how we can represent a single linked list in a circular form. That is the first node, second node, third node, fourth node. Last node is not having value null. We write the value of the first node. So you can change from 21 to 01. That is 109801. And if we talk about circular linked list, in Doubly circular linked list, the next pointer of the next node to the first node and the previous node to the first node point to the last node by making circular linked list. So the previous or the first node will become the address of last, and the next of the last will become the address of the first. So you can see over here, this is the first node. Earlier we write null over here in doubly linked list, but in circular doubly linked list, we write over here the address of the last node. The last node is connected to the first node, that is 109833. And the last node earlier was having a null value over here. Now it is having the value 109801. This address of this one. So it represents the first node of the linked list. This is how we can represent the circular doubly linked list. So in doubly linked list, the last link next point to the first link of the linked list in both cases of singly as well as double linked list, whereas the first link previous points to the last of the list in the case of double linked list. So you can see over here the previous or the first point to the last of the linked list 109833 109833, and the last one pointing toward the first one 109801 109801. So this is how we can represent the single or double linked list in a circular form. Again, the operation we can perform over here, we can insert, delete, display, and we can search also. That if we want to insert new element in the linked list, the element should have the three parts: previous, next, and data. If I want to delete some particular node from the linked list, a circular linked list or circular doubly linked list, then I have to first find that node in the linked list. If I find it, then I can remove it. And display means I can display all the nodes of the linked list. So this is all about the linked list.